to make the platforms actually shift from point A to point B and return to point A like they do during the gameplay. I didn't actually use scripts to accomplish that. I actually used the Martini, and I created a track and used keys to place where I wanted the platform to go and how I wanted it to return, or where I wanted it to return to, which would be the beginning point from where it took off to begin with, for it to be a consistent looping animation. So this is the timer script, and this is stored within the game mode itself. So there are two variables for this script. So there's the seconds as well as the minutes, and every frame there's a delay, and +1 of a second is added every second. And after that, a branch is used to check whether the seconds have gone over 60, and if the seconds are greater than 60, then the minutes are set to +1 and the seconds are reset for it to loop over and start again. Okay, so this is the menu to viewport script which I constructed and put together. So the event begin plays what triggers and starts the script in itself. So the event begin plays connected to the create menu widget, and within there is a class menu widget, and I was able to choose, so I had to use the drop down box to actually select the menu widget, which is what I had created prior to constructing the script. The menu widget in itself is what contains the buttons close down the window. The node next to it is basically saying add the widgets to the viewport for the user to interact with. So over here we have the quit and the start node script. So they're both triggered by click events. So for the quit one, so when the quit button is pressed or clicked, more specifically, it's basically going to shut down or quit the game. For the start script, when the start button is clicked, the level will actually open. This script in particular is what enables the health bar to be displayed on the heads-up display on the viewport. So upon the game being started, so for the event begin play, I used a sequence node as that just helped me keep everything fairly organized and fairly well structured. So I created the create health widget, and within the class plug I selected the health as that is what I wanted to add to the viewport. And from there I applied the player controller and I plugged that into the owning player of the create health widget node, as the control of the player is what is interfacing with the pawn. So from there I used the health bar variable and set it, and then added it and used the add to viewport node and plugged all of those together. So this script is responsible for the handling of the animations. I switched on the character states just to tidy up the script in itself. So the character states are linked to the appropriate flipbooks within the script, and the state variable is plugged into the character states. So the state variable is plugged into the switch on character states node for it to actually pump the information through into it in order for the character states node to function properly. So this is the script for the handling of the jump. So this script is carried out upon the key press event, hence the input action jump node to actually start off the script. So when pressed, the character is set to a jumping state, and when the character is jumping, the jump state is set through the animation state. So the jumping animation is played once the character is jumping. And upon release, the character stops jumping. Not instantly, however, the character gradually falls back to the ground. And upon landing, the character's animation state is set back to idle. So here the damage script is displayed. So I never actually implemented an enemy or a destructive pickup or anything of that nature into the game. So instead I implemented a key press which can be used to inflict damage upon the character. So since this is a key press event, the script begins from the pressed plug. So from there the variable health current is set, and so from there I used an integer minus integer and put 0.1 in, and from the plug on the upper left hand corner I connected that to the health current, and I got that instead of set it. So that was basically saying 0.1 of the health will be taken off every time the / key is pressed. From the variable health current set, there's a true or false branch. So if the branch is true, basically what will happen is the character will be set to a dead state. Okay, so the way the coin system script works is how many coins the player is in possession of, plus the amount of gathered coins from the coin system in itself. So this integer plus integer node here adds 1 every time a coin is collected from the player during the gameplay itself, and that is set to the character coins variable, which is also linked up to the coin system itself to finish off the script. So this is the coin blueprint script. So the on component begin overlap, which is a sphere. So here basically the overlap is connecting to the caster's 2D side scroller character, and I'm basically calling the coin system. So every time the character goes through or passes and collects the coin, I'm wanting 1 coin to go in. So I'm calling upon this function and telling it to add 1 coin, or insert 1 coin, add 1 coin to the score. Once that is done, the actor will be destroyed, because if it wasn't, then the coin would remain visible and the player would be able to continuously walk backwards and forwards and continuously go through it and continuously up their points by going through the same coin, which isn't supposed to happen. Okay, so here we have the animation state machine script, and the animation state machine was basically used to allow the character to cycle between different flipbook animations based on the defined criteria. So in the animation state machine node itself, there were a number of animation states. All of these nodes linked up to a branch which I had set, so for the death animation state. So I branched off from the death, from the BL death node, which by the way is my boolean variable. So basically what the script is stating over here is basically if the death state is true, then the state is set to dead, and I used the drop down box to locate dead, and that plugs up back to the return node. However, if it is false, it will move up to the next branch. So the animation state machine is a plethora of true and false statements. Okay, so over here I have 3 sets of scripts, all used for obtaining a certain animation at the event of pressing a certain key. So for the top script, that was used to get the attacks, to get the attack animation, or to get the attack state functioning. So I dragged off and added a set attacking state, and I had the attacking state ticked, and that linked directly to a flipbook, and under the new flipbook I selected the attack flipbook, as that was the flipbook I wanted to play. I wanted a delay for the attack animation, so the delay in itself was determined by the amount of frames in the flipbook divided by the frame rate to get the value you see in the duration. And once the duration was completed, the attacking state was cancelled. The same concept applies to the input action for the stealth as well as the running. So now I'm going to broadly mention casting and the situations in which I actually applied the scripting with the use of casting, as casting scripts worked exactly the same in every single instance. However, there were a few differences between the 4 casts I did. So I did a casting for the coins, minutes, as well as the seconds and the health. So for 2 of those, for the coins and the health, I was casting to the 2D side scroller character, and for the minutes as well as the seconds, I was casting to the 2D side scroller gamer. So in order for me to have begun script casting to begin with, I was required to create a bind from either a percentage or text. The cast would depend on where the information would be stored for it. So for example, for the minutes and seconds, I was required to cast to the 2D side scroller game mode due to the timer being stored within the game mode. So by establishing a communication link, I was able to obtain reference to appropriate variables depending on the script I was working on. I then linked it to the return value within the return node. And with the minutes and text, once I linked up the variable to the return value, it would convert into a text string for it to be displayed onto the screen heads-up display.